Alright folks, welcome back. Today's notes are going to feel pretty short. Hopefully you got to spend a little time outside yesterday afternoon. It was beautiful, at least near me. We're going to get into the same process but with trig functions now. So you had a few problems yesterday that involved a little bit of trig, but these involve more on the inside of the trig function instead. So feel free to join my office hours if you had trouble with any of those. But again, I'll post all the answers to your homework at some point today. So hope you're doing okay with those. Something to notice about trig functions is when you take the sine, cosine, tangent, whatever of something else besides just x, that should automatically become your u, because then you'll notice that du would just be 3 dx. One thing to notice here is that we can take the integral of the sine of u, and that's why we're able to do this. Something to notice is that there's a negative here, no negative here, so you have to factor that out. Okay, so we're going to take the integral sine of u du, okay, because we're literally taking the integral of this, the sine of that. So then you integrate and you get the negative of the integral of sine, which is negative cosine. If you need those out in front of you, you can use your former notes on that. Plus c, and then plug back in like usual. So we get cosine of 3x plus c. If you take the derivative of that, you'll notice, remember, the derivative of cosine is negative sine, so that's why the integral of sine is negative cosine, okay? The other way to do that is leave it as a negative sign, and you know the integral of negative sine is positive cosine. So that would have worked as well. All right, let's do this next one together, because something to be careful of is that you don't want to choose for u excuse me, secant, cotangent, or cosecant, because we don't know the integral of those. So this is a slightly different scenario where you know that the integral of tangent is secant squared, so that's why, or the derivative, I'm sorry, that's why we want to use that as our u. I don't know the integral of one of these, so that's why I have to be careful, okay? So in this case, u is tan of x, because du, the derivative of tangent, is literally secant squared. And notice that that is right there. So the nice thing is that we're just literally integrating. What's weird is that you're just integrating u du. So that literally just means you get u to the second divided by 2 plus c, substitute back in, and you get 1/2 tan of x squared plus c. If you want the nicer way to write that, it's really 1/2 tan squared of x plus c. That's like the nicer view of that problem. All right, I would like for you to try the next two. So pause the video, see if you can figure out what u is going to be. This is a little bit more challenging, but try them out for me, pause, and when you're all done, you will see the answers. All right, so hopefully you got negative cosine to the 4th x over 4 plus c, or if you had negative 1/4 cosine of the 4th x plus c, that also works. Just a reminder that we used cosine because it's literally going to be raised to the 3rd power, which helps us out there. I know the integral of something raised to the 3rd. I also know that the derivative of cosine is negative sine, so I have to factor out a negative there. Sorry, my music just went from meditation to something else. And then for this one, it's a little tough because you have to use u as sine of 5x. So you have to remember that du is going to be 5 times the cosine of 5x. Remember, it's chain rule, du. So when you integrate that, you're going to have to factor out that 1/5 because we have a 5 here. So in order to think about plugging that back in, of u to the 1/2 du, du had a 5 in it, but our original expression did not have a 5 in front. So that's why I have to factor out that 1/5. If you're still struggling with that idea of having to take things out, please stop by my office hours, aka join the meet. So either way, you get 2/3 times 1/5 u to the 3/2 plus c. Plug back in. You can simplify this a little bit and turn it into 2/15 sine of 5x to the 3/2. That's a 3 plus c. Okay, and again, if you want to write it here instead, that works as well. All right, cool enough. We are almost done these notes. If you need a second, we haven't done mindfulness, obviously, this week or last week. So if you need a little breath, feel free to take a deep breath in, let it out. If you need to pause the video and take a few minutes for yourself, please do that as well. The nice thing is you can kind of decide how long you want to take on this, because there's not a lot to do today, which is good. This video should be pretty short, and then you have a little textbook homework. So, all right, now it's asking you, notice, to find an equation for the function that is given the derivative that passes through the point. So what that does is it helps you find c. We've done a few of these before, but not with this type of integral. So if my derivative is this, they want the original function. Sorry, somehow I got muted, which was weird. Which means you have to literally integrate this to get the original function. Because remember, when you integrate a derivative, it cancels it out. So you end up with pi secant of pi x tan of pi x. Take a second and think about what your u is going to be. It's a little bit harder on this section because you don't want to use secant or tangent as u, which means, what is u going to be? That's right, it's going to be pi x. If you didn't realize that that's on the inside, and then you can integrate secant of u tan of u, because literally the integral of that is secant of u. So if you forgot that part, it's helpful to sometimes have the trig integrals handy next to you just to help you see what they are. So that means that du is going to literally be pi dx. So when we integrate, notice that this times the dx that should have been there is du. Then we have to take the secant of u tan of u du. Okay, so you don't actually have to divide anything out, which is kind of nice. The integral of that, so f of x, is literally secant of u plus c, which is secant of pi x plus c. Now that point comes into play because I can plug that in for x and y, right? So I know that I have f of x equals 1, secant of pi times 1/3, aka pi over 3, plus c. Okay, and you're solving for c at this point. So secant of pi over 3, think about what that would be on your unit circle, and ends up being, that's right, it's 2. Some of us are like, what? I don't remember that. So you end up with c equals -1, which means your final equation, I'll write it up on top, is going to be f of x equals secant of pi x minus 1. So now we know what c is, plugging that in. I would like for you to try the next one. If you need to get a little help, you can pause the video and come back to it, or whatever you need to do, but pause it, try it out on the next problem, and then when you are all done, you will have the answer, the final question of today. All right, and hopefully you got f of x equals 2/3, 8 minus x squared, all to the 3/2 plus 5 over 3. So feel free to check out my work if you had trouble with the fractions. Just be careful, this means raise it to the third power and then square root, or square root and then raise it to the third. So totally optional, up to you as to how you figure that out, but you should get 16 thirds there and then subtract, so you get 5 thirds. I hope you enjoy the rest of your day. You know, test out your homework, check all the answers when you're done, because I'm going to have them posted for you. And then feel free to join my office hours if you have questions. And have a wonderful weekend.